So what is the challenge that we're facing? Well, in any and all complex real-life systems with uncertainty, there are major challenges when it comes to decision making. First of all, it's really easy to make decision mistakes in these environments. And secondly, it's extremely hard to learn from the decision mistakes when we do make them. Why is that? Well, it's easy to make decision mistakes simply because there are always many more ways to fail than to succeed. If you think about a simple recipe, you have 4 ingredients, you have 4 steps, you have 1 temperature setting. How many ways are there to get it wrong? Well, many, many ways. How many ways are there to get it right? Very few ways. The same is true for projects. We have the same type of thing. We have a number of steps that we have to go through, a number of phases that we have to go through in order to deliver a project. There are dependencies between those. And of course, we have resources that we have to deploy, and those resources have to be available. Many of those things can cause failure. And as a result, it's pretty easy to find something to blame when we don't succeed, when we deliver late, when we deliver at a higher cost than what we expected, or if we don't deliver the full scope. Secondly, is that it's easy to make decision mistakes simply because the type of rules that we are using for planning the work in a project environment, the rules we are using to make decisions around the execution of that work and the measurement and improvement of that work, often the rules that we need for global rather than local optimization can be quite counterintuitive. And as a result, it's pretty easy to make mistakes from a local perspective. Multitasking, which is one of the examples I'll show, is like that. From a local perspective, it's extremely counterintuitive to not multitask. And lastly, why it's so easy to make decision mistakes is that often small changes that we might think are not consequential, can have big impacts, either positive or negative. Why is it so hard to learn from our decision mistakes? Well, firstly, in real life environments, typically large time and often space gaps between causes and effects. We are programmed and have the biology to learn very quickly from mistakes. Touching a hot stove plate, we can learn hopefully after the first such event, because it's easy to learn because of that short gap between the cause and the effect. I want you to think about a situation where, imagine if you got burned just a day later. How long will it take you to put those 2 events together to see the correlation? And if it's a week later or a month later, and that's often what we see in complex environments like projects where there's a large time gap between something that happened, either an internal or external change, and when we see the effect. And being able to go backwards, it's really hard. Secondly, as with the making decision mistakes in planning, execution, and in improvement, to learn from those mistakes, if the changes that we made was counterintuitive, or the changes that we need to make was counterintuitive, it's often very hard to put that. So if your project is late, before we knew how bad multitasking was, would you ever go back and look for cases where people were multitasking to come up with an explanation of why you didn't achieve the targets that you had set out? And lastly, as I mentioned, small changes can have big impacts. A practical example of this would be, imagine a company with 100 in sales and 5 in net profit. That could be $100,000, it could be 100 million, doesn't matter. A 1% increase in the average selling price of the products or the services or the projects that this company delivers. Variable costs won't go up, your operating expenses won't go up, so that whole value addition will drop to your bottom line. So your sales would go from 100 to 101, that 1 will drop to the bottom line. Your profit will go from 5 to 6, that's a 20% increase in net profit. Now imagine you get to your management meeting and you're trying to explain why your profits for the last month has gone up or down by 20%. How many people would think that we should check whether the average selling price of what we are selling didn't go up by 1%. And it's that element where small changes can have big positive or negative effects that make it really hard to learn from experience. So if this is the challenge, it's easy to make decision mistakes in complex environments. It's very hard to learn from them. When we do, is there a solution? And the solution that I'm presenting today is building digital twins, dynamic simulation models of these real life systems. Over the past, especially the past decade and maybe even 5 years, there has been massive advances in building digital twins that help us to overcome these limitations in a very practical way. And our goal with digital twins are very simple. We want to give access to decision makers to this technology so that it's harder to make decision mistakes, because we'll be able to predict much more accurately what the impact of our decisions will be. And secondly, that even if we do make a decision mistake, it'll be much easier to learn from our decision mistakes, because in a virtual environment, we can literally press the rewind button, go backwards in time and isolate what are those events that could have caused the effect that we are currently seeing in our environment. Before I get to the simulations, I'd like to share with you a framework that I've developed that can explain the types of decisions that could have an impact on the goals that we are trying to achieve. And I've separated these into planning decisions, execution, and improvement decisions. So let's look at what is the goal that we're trying to achieve. Is that we want to achieve more faster with lower cost. In a project environment, that would be achieving more projects, getting our throughput to go up faster, which means reducing the total flow time. That's both the time it's spending in backlog potentially, as well as in queue and in process, and at the same time to do that with lower cost. We obviously, the objective is that we do that to fully meet the demand that the system is placing on us. How are we going to do that? We know that in order to achieve more faster with lower cost, we have to continuously improve and synchronize the flow of work. And by continuously improving flow, we specifically mean reducing flow time in order to get flow rates up. Now, how do we go about doing that? There's essentially 3 leverage points in the system. There's planning decisions, decisions we make before we start the work, execution decisions, which is decisions we make while we do the work, and improvement decisions, which is decisions we made after we've completed the work. We can reflect back, we've got some measurements, and now we can decide what to change and what not. For each of these, there are essentially 2 categories of decisions. So in planning, the first of those categories has to do with decisions we make before we start doing the work that will involve how we allocate our resources, and specifically also our buffers. How do we buffer in order to reliably meet demand at the lowest cost? And how we buffer means not just the size of the buffers, but where do we place those buffers and what buffering mechanism are we going to be using? The second major decision is, once we've decided on the allocation of resources and how we're going to buffer, we have to make reliable commitments. We have to be able to quote reliable lead times, for example, but we also have to control and synchronize, based on those commitments, how we are releasing WIP into the system. I mentioned that there's a backlog component, which is before we release it. And then once we release it, it goes into process and into queue. We need a way of controlling and synchronizing the release of work. That's on the planning side. On the execution side, the first major category of decision and execution is, how are we actually going to do the work? Are we going to change the priority based on some local consideration or some global consideration of the work that's arriving? So we might decide to either process it in the sequence that it's arrived, or we might decide to change the sequence of arrival. How do we make that decision? And secondly, also, are we going to be batching or multitasking, or literally taking it one at a time? And then the second type of decision we're making in execution, which is a decision while we're doing the work, We are now working on the decision. We might notice that there's some problem, there's some delay. When should we expedite, and what should we be reporting? That's the second category of decision and execution. And then on the improvement side, we essentially have two categories of decisions on improvements: as what should we be measuring that will tell us how the system is doing as a whole, and what the causes of the performance is, rather than just measuring locally. And lastly, based on those measurements, when and where should we make improvements or adjustments, and when and where should we make investments? Now, in the framework, I'm sharing with you in this framework also what are the conceptual mistakes that can be made in each of these major decisions, and what is the principle that can be used